Converting and running Multisim offline and Multisim live circuits in TINA offline version. In this video, you'll learn how to convert offline Multisim and Multisim live circuits to run directly in the offline version of TINA. Whether your files are in the classic desktop MS13 or NS14 formats, or saved as msjs from Multisim Live, TINA handles them smoothly. Even better, the converted .tsc files worked seamlessly in both offline TINA and TINACloud. One file format, one workflow, offline and online, without missing a beat. FM Demodulation Circuit. To show you how the conversion works, we'll start with an FM slope detector circuit. We have this circuit file in both formats, so let's begin by importing the Multisim Live version first. Start TINA, and from the File menu, select Import, then Multisim File. Select the FM slope detector.msjs file. The converted circuit will instantly appear right inside the TINA editor. Next, let's import the offline multisim.ms14 version into the TINA schematic editor. The same schematic diagram appears. This design is configured to process a frequency-modulated signal with a 500 kHz carrier and a 40 kHz modulating frequency. Parameter check and waveform organization. First, verify the signal parameters to ensure the carrier and modulating frequencies are correct. Double-click the voltage generator, then click the Details button in the signal field. The FM signal parameters appear, along with a preview of the signal. To optimize the output display, we will modify the PR4 output label. By adding :1 to the label, we can separate the curves and move the PR4 trace to the top position in the diagram. Transient analysis and verification. Now run a transient analysis. Once the results are displayed, zoom in on a few periods of the modulating signal to get a clearer view of the FM signal and the demodulated output. Cursor measurement. To verify the results, place two cursors on the PR4 output waveform. Measuring the time difference between neighboring peaks allows us to determine the signal period and confirms that the output frequency is indeed 40 kHz, matching the original modulating signal. Our next example is a digital circuit in the Multisim Live.msjs format. We will demonstrate how to convert and run it in TINA. This feature of TINA is especially valuable because Multisim Live does not currently support conversion of digital circuits to the MS14 format, limiting their use in the offline Multisim environment. In contrast, TINA provides seamless conversion of msjs files and allows the converted circuits to be simulated in both TINACloud and the offline TINA environment. To start, use the Import command to open your file in TINA. Testing the digital circuit. Once the circuit appears in TINA, we can begin testing. A great feature of TINA is its ability to display digital states, not just on the output, but on any visible digital node on the screen. To start the interactive digital simulation, press the Dig Interactive Digital button. Let's change switch A to high. You will see the state change at the sum output. Next, if we set the other input switch to high, it again appears at the sum. However, if both the A and B switches are on, both inputs are high, the sum becomes low and the carry becomes high. This confirms the standard operation of a half adder. VHDL and Verilog subcircuits. TINACloud and TINA also offer another powerful feature. Digital circuits can be described using mathematical formulas or programming languages. In particular, digital circuits can be modeled and simulated using hardware description languages, or HDLs, such as VHDL and Verilog. The importance of VHDL and Verilog lies in the fact that these descriptions can be synthesized into integrated circuits, such as FPGAs, which are a standard solution in modern electronics. To demonstrate this method, let's add two subcircuits into TINA, the half-adder VHDL and half-adder Verilog macros. The upper circuit shows the description of a half-adder using VHDL syntax. This code is placed within the macro. To view the code, double-click the macro and click the Enter Macro button in the half-adder VHDL dialog box. The HDL code window will appear. Similarly, you can view the Verilog equations within the Verilog macro. Now let's close these windows and compare the results in TINA's interactive digital mode. Comparing results. Now press the interactive digital button again. If only one input on the original gates is high, the sum is high. You can see that the VHDL and Verilog macros produce the exact same result. Now, let's test the case where both inputs are high. In the original circuit, the sum is 0 and the carry is high. The VHDL and Verilog representations match this perfectly. Why use HDL? Today, it is very common to describe digital circuits using HDL code instead of building them from individual logic gates. Hardware description languages such as VHDL and Verilog allow designers to work at a higher level of abstraction, making development faster and more efficient. While this example is simple, the same approach is used for designing much more complex digital systems. For more information on creating and uploading digital circuits to Xilinx and Intel FPGA boards using VHDL, Verilog, or schematic designs, visit our YouTube channel, www.youtube.com/TINADesignSuite. Our next example is an active bandpass filter created in the offline Multisim program. Save the multisim.ms14 or .msjs file to your hard drive, then import it to TINA. The schematic will open automatically in the TINA circuit editor. You can save the circuit locally in TINA-TSC format using the Save or Save As command. Configure AC analysis. From the Analysis menu, select AC Analysis AC Transfer Characteristic. In addition to AC Bode plots, TINA can calculate amplitude, phase, Nyquist, and group delay diagrams. Set parameters and run the simulation. Select the AC Bode, amplitude, and Nyquist diagrams, and set the number of points to 1000 for a high-resolution output. Then, click OK to execute the analysis. 3 separate tabs will appear, displaying the amplitude diagram, Nyquist diagram, and amplitude and phase Bode diagram. Symbolic analysis in TINA and TINACloud. A unique feature of TINA and TINACloud is the ability to derive a circuit's transfer function symbolically, presenting it as an exact mathematical formula. This allows engineers and students to gain deeper insights into circuit behavior, including poles, zeros, gain, and frequency response. This symbolic expression can also be used for analytical studies, documentation, optimization, and verification, moving beyond a sole reliance on numerical simulation results. Note: while symbolic transfer function derivation is only possible for linear circuits, you can still analyze active filters. Replacing nonlinear operational amplifier models with ideal op-amps provides highly accurate results, allowing the transfer function to be derived and analyzed symbolically. Running the analysis. Go to the Analysis menu. Select Symbolic Analysis, AC Transfer, and run the analysis. The analytical form of the transfer function will immediately be displayed on your screen. Documenting the schematic. You can easily add this symbolic expression to your schematic for complete circuit documentation. In the equation editor window, click the copy icon or choose Edit, Copy. Next, switch to the TINA schematic editor and select Edit, Paste. The formula is now attached to your cursor. Position it wherever you like on the schematic and left-click to place it. Note that you can also edit the formula using the Settings tab in the equation editor, though we won't cover those features in this tutorial. Plotting and comparing results. Beyond formulas, you can also plot the analytical transfer function to compare it directly with your numerical simulation results. In the equation editor window, simply click the Interpreter Calculator icon. Then, inside the interpreter window, press the green arrow to run it. The plot of the transfer function will appear. To make comparing the analytical and numerical results easier, click on the curve and change its color to green. Next, click the curve again, then click the copy curve icon to save it to your clipboard. Now switch back to the previously calculated Ample 1 tab and use the paste curve icon to overlay the symbolic result directly onto the numerical curve. As you can see, the two curves match almost perfectly. This example also demonstrates, as mentioned at the beginning, that replacing nonlinear operational amplifier models with ideal op-amps yields highly accurate results for active filter circuits. This is why ideal operational amplifiers are widely used in filter synthesis. Inverting DC-DC converter. Our fourth example is a DC-DC converter based on the MC34063 switching regulator from onsemi. This circuit efficiently converts a plus 5 volt input down to a minus 12 volt output and is available in both msjs and MS14 formats. Both can be converted to TINACloud and TINA, where they run at identical or even faster simulation speeds. To convert an MS14 circuit, first save the file to an easily accessible location on your computer. Next, import the file into TINA by selecting File, Import. The converted schematic will instantly appear right inside the TINA circuit editor. Running the analysis. Navigate to the Analysis menu, select Transient Analysis, and run the simulation. Once the results display, we can separate the curves and adjust the current axis limits to get a clean, detailed view of the waveform. Customizing the waveform display. In the diagram window, click the View tab and select Separate Curves. Next, click the PR1 axis and enter the values shown on the screen. Then, repeat this exact procedure for PR2. Note that TINA and TINACloud include a large number of DC-DC converter ICs and evaluation circuits from leading manufacturers like Texas Instruments, Infineon, Analog Devices, Nishinbo Micro Devices, Worth Electronic, ST Microelectronics, and Semtech. That brings us to the end of this tutorial on converting offline multisim and multisim live circuits for use in the offline version of TINA. For more information, visit our website at tina.com. Visit our YouTube channel, youtube.com/TINADesignSuite.